Okay, in this video I'm going to introduce you to the concepts for analysis of variance, and we're going to refer to this mainly for our more sophisticated kinds of designs. But I'm going to start with this one-way analysis of variance because you've now hopefully calculated one on your own by hand, and you have a good sense of how this works and how we partition the variance in this particular example. And so I'm going to use this to set up, this is how we'll talk about our other designs in a more complex way, as well as how to do them in SPSS. So just to refresh your memory, this is when we have one IV between groups, right? We're doing just a simple, completely randomized design with an F test on that. So here's the table of data, and S1 represents first subject, right? So that's the reaction time for the first subject, reaction time for the second subject, third subject, fourth subject, fifth subject, and so on. S6 represents the sixth subject through 10, right? 11 through 15. So we have 5 members in each group, each with different response times. That's our dependent variable, as you can see up here, okay? So as you know, we can have a source table, and the source of variance, one of which is due to the IV. This would be our between subjects, right? So our IV is a source of variance. There's degrees of freedom. So this is degrees of formula for the degrees of freedom for between groups, k minus 1. We have a sum of squares. So here is the formula, sum of squares between groups. We have a mean square, which is this, sum of squares between groups, divided by sum of squares degrees of freedom, right? We have a source of variability within our groups, which we're calling error variance. We don't know what causes this, but we're calling it our error variance. The degrees of freedom here is k times little n minus 1, little n meaning the number of subjects, or in this case 5, minus 1 or 4. Sum of squares within groups, there's a formula for that, right? And you've done this before. And the mean square is sum of squares within groups divided by the degrees of freedom. Of course, there's formulas for a total sum of squares as well. The F is this value, mean square between groups, divided by mean square within groups. Right, that's the F value right there. And if we were to take this data and put it into SPSS, you would end up with a source table much like this one, flipped over. Of course, SPSS flips it over and has the error variance on top. But here it is, and this is the analysis. And of course, the P is less than 0.5, so it's significant. That 0, 0, 0, SPSS only goes out to 3 decimal places, so that just means that it's less than 0.001. So that's how we're going to look at our more complex designs. Next, we'll talk about the source table for a repeated measures design. We'll use the same data, but we'll talk about it in a little bit different way to sort of set it up.